Welcome to Argo Unpacked.
All right, today's episode is all about Argo rollouts. We're going to talk about some new features coming to Argo rollouts, like header-based routing via Gateway API. And we're also going to look at how you can embed AI agents into progressive delivery to do health checks. And this tip of the week is going to be focused on why you should stop trying to rebuild Argo rollouts inside of Argo CD with a bunch of duct tape. All of that coming up on today's episode of Argo Unpacked. So if you aren't already strapped in with your popcorn, your soda, your drink, I'm going to be sipping from my Argo mug. Oh, fantastic. We're ready to go. So before I bring the folks in here, we've got a little bit of a tip for you.
Tip of the week.
All right, every week on Argo Unpacked, we do a tip. We help people understand some of the best practices, the do's and don'ts with Argo CD. One of the things that today's tip is stop trying to remake Argo rollouts inside of Argo CD using duct tape. This is actually kind of a common anti-pattern that we see, where we see people abuse the rollback mechanism of Argo CD to try to get to something like an Argo rollouts. Now, the way that Argo rollouts work, for those of you who don't know, you replace the deployment object with a rollout object, and it can actually just consume an existing deployment object. And what it will do is you can set up a plan where it will divert some portion of traffic to your new version, and it can run health checks. And when it fails, it can automatically roll back to the old version. And this is all handled seamlessly in the rollout object. And this pairs really well with Argo CD, because when you have Argo CD sync a new rollout version, it will then let Argo rollouts do its thing and slowly expand that traffic out. Now, of course, Argo CD does not have a mechanism to control traffic like Argo rollouts does, but Argo CD does have a rollback feature. So you can actually tell Argo CD to roll back to a previous version. But the biggest issue with this is that in order to use that, you have to disable autosync. And once you've disabled autosync, you no longer can just look at Git and know exactly what's deployed. Now, Argo rollouts, because within its structure, because within its schema, it actually says, we want this new version, but if that version isn't working, this is the old version that should be working. We actually have a built-in mechanism to decide how that rollout should happen. And in a previous tip, we talked about how you can version your config maps. And that works really well with Argo rollouts. So you can have different configuration going between an old version and a new version. When you're using Argo CD to try to do rollbacks, you may be able to do it temporarily to fix an issue where something, didn't deploy properly. But because you lose autosync, when you go to fix it, you're going to have to deploy a new version, obviously, and then manually resync it or re-enable autosync. So it's just not the best way. It's just not the best place to do that. The best way to de-risk your deployments in that way is using Argo rollouts. And a lot of people have tried to build something like Argo rollouts using Argo CD plus a lot of post-sync hooks or sync fail hooks or those kinds of things that will then trigger different custom functionality. And while that's possible, it's probably better just to use Argo rollouts to do that. So that's your tip of the week, is don't try to rebuild Argo rollouts inside of Argo CD. So that's the tip of the week. Now, on this episode, we do have some news to cover, but I think what we'll do is let's bring in our guests first. So let me introduce our folks here.
Argo Unpacked special guests.
All right, so this week I'm joined by Carlos from Adobe, Kevin Dubois from IBM, and of course the enigmatic, inexhaustible Kostas Kapoulonis, from whom that tip comes. So Kostas, you're on mute, but did I miss anything with the why you shouldn't with the Argo CD, Argo rollouts, duct tape? Is there another point to add to that?
No, I think it's also something that we should fix in the documentation. So, introduction, I'm Kostis. I'm a developer advocate at Octopus, but I'm also a member of the Argo team focusing on Argo CD and rollouts. So it's our mistake that we don't have enough documentation explaining how Argo CD rollbacks work and how Argo rollouts rollbacks work. Because sometimes people get confused, they don't understand, what is the difference, what is the similarity there. So we need to be more clear. On the Argo rollouts side, there is the FAQ page, and it tries to explain this concept. So be sure to check the FAQ at Argo rollouts, and it explains that rollouts is something completely different than what you already know with Argo CD rollback. So if you're using Argo CD rollback, forget about it. Come to the dark side or the white side of Argo rollouts. Other than that, I agree with everything that you said.
Now, Carlos, Kevin, any reaction to that? Is that something that you've seen from any of your users where they've tried to kind of abuse Argo CD to start doing Argo rollouts jobs?
I mean, yes, because we see customers abuse pretty much everything that they can use. Because they think Argo rollouts is another thing that they then have to maintain and do stuff with and learn. So they just try to do everything inside, in this case, Argo CD. But yeah, I don't know, Carlos, if you've seen similar things.
Not on my side, because now I'm the customer side. So
so everything on your side is perfect.
Using it now.
We don't abuse anything. Everything works perfectly. No need.
No, I mean, it is pretty common, Kevin, to your point, like people want to use a single tool. So we have seen people take Argo workflows, for example, and be like, oh, let's use this to do all of our CD stuff. And of course, that's, it's like, well, there's another tool that's actually really good at that. It's called Argo CD. So you don't have to do everything there. And it's similar with Argo rollouts. Now, of course, you can use these tools independently. Salesforce famously uses Argo rollouts everywhere and doesn't use Argo CD. So they can be used without using both of them. But in general, each one has their own job to solve, right? So if you're trying to solve that job, use the tool that's designed for it. So today we are going to talk about using AI agents as part of your rollout. But I think we wanted to cover first, Kostas, the news that we're bringing header-based routing into Argo rollouts via gateway APIs. So do you want to take a minute and just kind of introduce why that's important?
You have the article open on your screen, Dan?
Yeah, let me see. I'll pull it up. Hang on.
So this is actually on the official Argo blog. If you don't know anything about the official Argo blog, you should. It's on Medium, so you should go and subscribe, because all the Argo developers go there and make announcements every time there is a new release for Argo CD, for example. It's there, and you can see which are the major what are the major features, who are the people that contributed, and what you need to know about migration. So right now, the last post is not about Argo CD, it's about Argo rollouts, and it's a post I created, where essentially we talk about, you can scroll down, this is just the intro. We talk about header-based routing. So this is a feature of Argo rollouts where instead of just saying, I want to send 20% of the traffic there, and it's completely random, this is what happens by default, this 20% is random. Instead, you say, no, there are some customers and they have a special HTTP route and a special header there, and for them, I want to send them to the canary. So the pretty common scenarios will have maybe your QA team, or maybe some special customers, or maybe you select a territory and you say, I want France to see the canary first, and then you point them there. So this is a great feature. It's an amazing feature. Everybody's using it, but until recently, it was only available for Istio and I think one more traffic provider. So if you had, Istio, you were happy. If you didn't have Istio, you were sad because you could not use this feature. So that's sad. But then, as you might know already, there is a new kid in town. It's called the Gateway API, which is the next generation of Ingress. If you're on Ingress, you should look at Gateway API. And for Argo rollouts, there is a plugin that we maintain. When I say we, I mean Octopus. And it's bringing all the capabilities of the Gateway API. So this means automatically you get support for every traffic provider that supports the Gateway API. And we added header-based routing exactly the same way as Istio. So now you can use this nice feature with your favorite traffic provider. If it supports Gateway API, you can use it and you don't have to use Istio anymore. You can still use Istio. I mean, even Istio supports the gateway API. But if you have like another traffic provider, you can do it. So more power to the users. That's the new feature.
Yeah, I quite like Gateway API because you don't have to get into the implementation of what ingress you're using. You can just have it work with any of them. So that's quite nice. And then one of the issues with header-based routing from a user perspective is like in Argo rollouts generically, you might have somebody go to a new version of a service that relies on like another microservice that was also updated. But if you don't have header-based routing, there's no way to like keep that consistent between the different services so that you always have people always getting the same version on the different services that you expect them to do. But with header-based routing, you totally can do that. And you can make decisions about like about who's in that group. So you could do things like say, oh, this is our very high grade SLA user. Their header-based routing, they never get the canary. They always get it last. You can make decisions about like who gets stuff first, who gets stuff last, and get a lot more granular control. Now, this is while we're talking about abuse of tools, this does start to get people to be tempted to be like, hey, is this a feature flagging tool? Right? Because you kind of squint and you kind of make it act like a feature flagging tool by using this header-based routing.
Dan, do not give him ideas. Come on, please, come on.
Which we would say you probably shouldn't do. Yeah, very cool. So you can go and use this plugin now for free. You can read all about it on the Argo blog. And instead of writing configuration specific to Istio, you can just write generic configuration to Gateway API and let it be handled. And if you ever are deploying to AWS and you're using an ALB or you're deploying using HA proxy somewhere else, you don't have to change the configuration. It'll just work. So magic. So that's the news. Kevin, Carlos, anything you want to add or reaction to that?
I'm already thinking that, hey, this is actually another good use case for our AI agent that can go to the, based on the header, can already check out the canary and look for any kind of iffy stuff in the UI as well.
All right, so that's a perfect intro, actually, to today's topic, which is embedding AI agents into Argo rollouts to use it as part of your decision-making tree. So why don't, let me pull my screen off here. So Kevin, do you want to introduce for us kind of that idea and where you guys started from? And most people haven't seen the KubeCon talk. We're going to be talking about a talk that you and Carlos gave together at KubeCon, but just to introduce that idea and like how you came to it and how it started.
Yeah, so Carlos and I have been doing talks on progressive delivery and for a few years. So we were just talking about, some interesting ways of how we can use that. And we're both experimenting with AI. And so we were like, well, actually, it's always kind of annoying to write the PromQL or whatever to figure out what kind of metrics we need to look for to decide whether a rollout is good or bad. And actually thinking of AI, that would be cool if we could just throw a bunch of stuff at it, metrics and logs and whatever we can think of, and then let an agent kind of analyze that and roll it back. And so that's kind of how it started. And then I guess we got to some solution. I think Carlos was you wrote the first iteration, I guess. And then we also figured, well, if it can analyze the issue, maybe it can also try to fix the issue. So we also tried to see like maybe it can create a PR or at the least create an issue with the description of the problem. So yeah, that's kind of how it all started. To just use AI for use case like that. And so we've experimented with it quite a bit over the last year, right, Carlos? Because at the start it was a little bit on the slow side, and it's like, well, we want something that makes a decision pretty quickly on whether a rollout is bad or not, because that's always downtime for, even if it is based on the headers, and it's just your QA team. But like somebody's going to be affected. So the quicker that we're going to be able to roll back, the better. So we worked on that part as well.
Yeah, I think the first iteration was just a job in Argo rollouts, and then it was fairly easy to say to some agent, just convert this into a proper plugin. And yeah, as Kevin said, the use case is, how do you know a rollout is bad when you don't know what to look for, right? When you have these unknowns where you don't know what's the, I mean, you may have the default metrics, I don't know, 500 errors, whatever, something typical. But what happens when a problem that you didn't expect happens, right? It's like unit testing. You can test for things that you know it can fail, but you cannot test for things you don't know that they can fail. So it was a bit of the same idea. And I think that this could be complementary to whatever you already have. Whatever metrics you already have, and then you just sprinkle a little bit of the AI analysis on top, and then we'll try to find things that you didn't know could go wrong.
Yeah, by default, if you just add Argo rollouts, it'll detect like pod failures. It'll be like, oh, this pod isn't starting, failure. And then you can go the next layer deeper is like, oh, I want you to check, how fast it's responding, or I want you to check memory usage, or like you can set these different parameters. But I noticed that is a common barrier for Argo rollouts, that a lot of people don't know what they should put in. They haven't done like a profiling of their service to understand what those failure conditions might look like. And it is difficult to predict every kind of failure that could be produced. There's a famous quote from, I think it's Hayek, who's talking about economics, and he says they have fixed the error that caused the last crash, and they can guarantee that it will not fail in the same way again. It'll fail in a new way. And that's kind of what we do as engineers sometimes, is we're like, hey, I wrote a test for it. I can guarantee it will not fail that way again. Instead, it will fail in a new way that we could not predict, and we'll just experience failure anyway. I think the pressure for this is much higher now because people are shipping a lot more code. When you start shipping more frequently, if you don't have a way to de-risk that deployment, you're going to have way more downtime. And I think we've all seen that from companies. AWS had a lot of downtime recently. GitHub getting the hug of death from everybody. So, AI is great to help us ship software, but unless we can find a way to use it to also help us de-risk that deployment, we're going to be in a lot of trouble. In this case, are we just talking about like dropping Claude into a job, or is it something else?
Yeah, Carlos, if you want to.
Yeah, right now, so the plugin for Argo rollouts is a very basic. It just calls an agent using the A2A protocol. So we have a couple of examples of agents that would do the analysis for you, but it could be anything that you want, right? Anything specific to your company, to your use case, anything you wanted to do, as long as you respond to on the A2A protocol, then that would work. The agents we built, they started very basic. Okay, here you're an agent, you have access to kubectl, and you have access to the metrics. And then I think we built it with AI, also saying, okay, build me a A2A agent that would check for errors, generic errors on Kubernetes. So that's what it was doing. And then on the next iteration, we went into the multi-agent orchestration, right? The idea that you could have multiple agents, each of them specializing on different areas, just to showcase how this could work, right? You could have an agent that is an expert on metrics or analyzing the metrics, and one agent that could be an expert on your examining the logs, one expert that is more into, I don't know, Kubernetes failures, and how they can all talk together to figure out what's wrong.
So this way, okay, as you've implemented this, have you had any surprises where you discovered new failure conditions you didn't expect, or is this still in the more experimental data gathering phase?
Is it more of an experiment right now? There's nothing preventing. I mean, as I said, the plugin is very simple. There's nothing weird about it. It's how you would build an agent that codifies the knowledge that you want to check for.
Yeah, I mean, because the demo, we've just been using demo apps to basically trigger some failures, right? So very similar to the kind of standard demo app for Argo rollouts. I created a new demo app, and then basically there's of course the happy version, and then there's the version that triggers some null pointer exception, and then there's one that causes a memory leak. And so which are two different scenarios, because one you're going to find in the logs and the other one you're going to find more in the metrics. And so so basically based on whatever we throw at it, it starts to look at all the data and then makes a decision. And then so we on the remediation side, what we did was basically in our first iteration, we did a remediation kind of by creating an issue in Git, and then having an external code assistant kind of examine it and try to fix it. And then in a newer iteration, we actually have the little agentic system that does analysis now does also the remediation, and is also going to try to create a pull request. So it's analyzing the code and then trying to fix it. And the reason why we wanted to do that is to try to have everything kind of in this system, so that we don't have to rely on, like then you have a dependency on, I don't know, Copilot or Jules or some other tool. But again, that's totally up to the user to decide what they want to do, because we just created an example that's open source, and they can take it for what it is, or they can completely customize it to what their needs are. But for me, it was more interesting to just do something that used my models that I have available from the Red Hat side, because we have this model as a service thing. And so I have, a couple like a Qwen 35 billion and a Qwen 4 billion and some DeepSeek models and whatever more. So I can just throw them at the problem, and I don't need to worry about my token usage, which was pretty useful throughout the working on this stuff, because otherwise I think it would have cost me a little bit of money at least, because analyzing for issues is, let's say, relatively not that hard. You basically go and fetch the logs and metrics from, in our case, directly from the pods, but it can also be, like using OpenTelemetry or getting it from some centralized logging system. And then you structure that data and pass it on to an LLM, and it's pretty good at analyzing that, even with a relatively small model. But the remediation is a bit more complicated, because it really needs access to your code and analyze that. And if you have a bigger code base, then the context needs to be quite big. And so there were some interesting challenges with that. But in our example, at least, we're still using just an open source Qwen 35 billion to do that stuff. But it's been an interesting challenge to get it all working.
Yeah, the Qwen 35 billion, I think, is a general mix of experts model. It's not even coding focused anyway, but it's
right,
quite good. I use Qwen too. I use Qwen 3.6 as well. There is something to be said about token anxiety. This is like the new range anxiety for people on electric vehicles. It's like, I want to do this project, but I've got token anxiety for how many tokens it's going to use. And it's like, no, it's okay. I'm just running Qwen on my local machine. It can go all day, night, doesn't matter. Because I don't have to worry about the tokens. There's definitely like a set of people who are anxious about it, because you get worried about like using too many tokens. In my case, it's just like, well, it runs a little bit slower because it runs on my AI box back there. Maybe it's not as fast as what you pay for, but You know,
Yeah,
if
you definitely
if it's running
see.
agentically, you actually kind of don't care if it's fast, right? You're like,
yeah,
it took an extra 3 minutes when I wasn't paying attention to it. What do I care? That's why kind of one of my favorite things about having a home lab is like, yeah, so many of these things are running, you know, off sync when I'm not looking at it. Like I don't have to have it be super fast. I just need it to get done at some point. Great.
Yep.
So
Yep.
To the point that you were saying before about the guardrails, I think this is it kind of fits very well. I see that more often now where, yeah, what you said, we are shipping more code. Whether it makes sense to ship that much or not, that's a different question. But the fact is that we are shipping a lot more code. And now there's no time a human can review everything. So either people tell you that if they're telling you they're reviewing every line, they're lying, or they will just not do it. I mean, I don't have the time to do it. Otherwise, what's the point of writing 10 times the code if you can just read one at 1x speed as before? So I think it's key now. And I don't know if AI is going to manage to encourage people to do the best practices we were talking about for the last 15 years or so, about CI, CD, canaries, all this stuff. Because right now you have a very good chance of getting more failures. Even if you have the same rate of failure, if you ship 10 times more,
you get 10 times
the rate of
failures. Yeah.
Yes.
Yeah.
So
plus it becomes much harder to fix because nobody has reviewed every line of code, like you said. So yeah.
Well, this goes to that. Your question about the thing you're saying about best practices, I think is a very good one, because in my experience, AI is best when it has a rigid set of rules that it has to follow and meet. And when it can go beyond that. So for example, if you're like, oh, I want you to fix this server issue, AI is very comfortable doing something that humans would not do. It's like, oh, sick. I'll recompile a kernel that has that module in it. I'll hot load it in and over, and you're just like, oh, don't do that. Like, that's it. You're going to make the system unstable. Like, this is like, if it fails, you're going to destroy the system. And AI is very happy to do this like direct hack solution because it's easier from like a context standpoint, that it can just be looking at one thing. But when you say like, oh no, you have to be doing GitOps, you have to actually commit this, it needs to go into a pull request review, like it needs to go through this process, then suddenly it's like, oh cool, like these abstraction layers that we've introduced via GitOps and like these check-in points and gateways makes the process auditable. That actually makes me trust it more than like, oh hey, I reminds me, I heard a crazy story. I don't know if this is true or not, but years ago, somebody said that they were trying to optimize this codec running on a machine, and they threw machine learning on it to have it execute, and they just let the machine learning run for weeks at a time to get it to optimize this function or whatever. And when they came back, they had gotten it so optimized that they couldn't like justify how it would work. They were like, this is way too optimized. It doesn't make sense that it would be this fast. We're getting into like violating the laws of physics. So they took it and they tried to install it on another machine, and it didn't work. And it turns out that the machine learning had optimized for the hardware that it was on, and it had found that there were these imperfections that caused like quantum entanglement conflicts that the system was able to build off of. So it was able to be incredibly optimized, but it could not be generalized because it was specific to like the imperfections of the chips.
It works on my machine. That's the definition.
I was just gonna say the quintessential,
right? So yeah, you could see a world where it's like, yeah, I can let AI run this thing, but it's gonna be so specific, and it's like there's no way to test it, and like nobody knows what's happening. It's to become a total black box. That's where it starts to get a little scary, because even another AI agent coming in to review that won't know where to go because it's so far down the rabbit hole. So having it be committed back into Git feels like actually a really important thing at the end of the day.
your story about the kernel is funny because I was in the opposite side. I had a small board like a Raspberry Pi, where the image that they got an Ubuntu image and the Wi-Fi was not working. I throw Claude into it, and it went and recompiled the kernel models and made the Wi-Fi work. And then I was like, okay, just submit a PR upstream, and they accepted it. So I got my board working with Wi-Fi that even the company building the board did not care about.
No, well, I had this with I installed Bazite, which is like a immutable cloud native OS. So like,
Come on, Dan, it's gaming Linux. Say it, it's gaming Linux.
Yeah, it's gaming Linux. Yeah, I installed it on an old iMac, and I was like, oh, this works great. Everything works great except for the sound. And so I just threw Cloud Code at it, and I was like, hey, this sound doesn't work. The driver's not available. Somebody made a driver for Linux for this board, but it's not available on this OS. And it proved that it worked because it did this kernel recompile, and of course it wouldn't persist through boots, but it proved that the driver worked. So then it was like, okay, now go and actually do this the way that the operating system wants it to be consumed. And it fixed it for me. And I committed the code, threw it into GitHub, and we'll see if anybody accepts it upstream and wants to like include it. I was quite impressed with it. I was really, really happy. But it was one of those situations where like it worked really well because the AI could try over and over again different things. And so it could be wrong 75 times. And then it just got it right once. And then it's like, cool, documented that, done. And we do that as humans too, right? Like we all the time are like, oh, something is wrong. Let me start troubleshooting. I'm going to try this. I'm going to try that. And we're wrong. We're wrong about all those things. Then we finally find the one thing that works. And great, we're saved.
Learning the process.
Yeah, we're learning the process. So to bring it back, I'm sorry, to the steps. I think conceptually what you're talking about is, you have a rollout, an analysis template that has essentially embedded jobs that kick off these agents to run, and then they can do an analysis, and they're going to send back to Argo rollouts essentially a pass fail that says like, hey, this looks like something weird is going on. I think this is a fail, or it looks fine. It's a pass. And when it fails, then you kick off a rollout failure job that will start the remediation process, open up a GitHub issue. Once you've opened the GitHub issue and you've given the feedback, then the work shifts into a CI process where there's an agent that's watching for these issues to open. Once they open, it checks out the code and it starts trying to create a remediation that would open a pull request and then would attach back on. Is that the basic flow outline of how this whole thing works?
Yeah, totally. Yeah, you tell the agent to go and create the issue, and then you could say as Kevin mentioned, you could have an agent that tries to fix the issue and create a PR, or I have done demos with using Google Jules, which is basically just attach a label to the issue when you create it, and then Jules eventually comes, fixes it, and it's great to show how in like 3 minutes you went from I rolled back because this didn't work to here is a fix for the thing that you can just commit or merge, or even automatically merge if you are YOLO mode.
Yeah, YOLO mode.
And then you get the fix.
Unlimited token mode.
Somebody is saying they need the GitHub repo.
Yeah.
Where's the GitHub repo?
Well, it's in the Argo sandbox.
Yeah, the plugin itself is in the Argo Project Labs sandbox thing. And then I think all the other repositories are linked from there for the actual demo.
What's the repo called under the Argo Project Labs?
Rollouts plugin
metric AI.
Oh yeah. Okay, I got it. Okay. So I'll throw this into the chat for everybody.
I think it's important to help the audience understand something. Originally, when Argo rollouts, was in the early versions, everything was fixed. You got Argo rollouts, and it had specific support for traffic providers and network providers. But then and now when I say we, I mean the Argo team, we moved into a plugin architecture where you can create a plugin for your metrics, a plugin for your traffic providers. So what Kevin and Carlos are talking about is an implementation of a plugin. Okay, correct me if I'm wrong. It's an implementation of the plugin specification that you can use in your own. It's completely unrelated, to all this. You can write your own metrics plugin to do whatever you want. So the repository is an implementation of that API. Correct? Yes?
Yes. Yeah, it's the plugin, and this plugin is not very smart. It just calls an agent. You have to have an agent running, and there's links here for these examples. And it just goes and calls using A2A the agent, and then the agent in the prompt is give me whether this succeeds or not based on whatever the agent thinks. Give me a reason and give me a confidence score also, which I think it's also interesting. So you can tweak how much confidence you want from your AI agent.
Yeah, exactly. We have 2 loops to check for the quality, one on the analysis and then one also on the remediation side. So when it's about to create the PR, we also do like with another agent a check that that it really is a decent enough fix before it actually creates the PR. So yeah, again, it's all just custom and open source. So it's an example of how somebody can use it. You don't have any plans to commercialize this.
You could use just one agent. That would be fine too. But I think one thing that I thought is great, is the remediation part. You get issues created that are so good that even a human could understand better. But then even getting that a PR suggested for you, that's amazing.
Yeah, it's nice to work off of something and having some baseline of like, okay, here are the metrics that were gathered. This is the reasoning for why this would be the fix. And I could have, and lots of times as a human, you can look at those and you can kind of immediately be like, oh, that doesn't make any sense at all. This is off base. Or like, oh, actually, that sounds like it would make perfect sense. And either way, you're going to get a piece of data that you didn't have before, and it's coming pretty much immediately anyway. So not bad.
Yep.
Yeah, very cool.
Do we want to see this in a demo? Do you want to see it in action?
Yeah, let's do it. Yeah. That
right.
sounds cool. Yeah, let's do that.
Let me share my screen. I have to make sure to select the right screen. All right, so this is my craptastic UI for the actual demo app, right? So if you know the Argo rollouts demo, it's kind of similar to this. The user, I based myself on that. But so right now it's actually receiving the events from the agent that is going to post here. But so I now I'll start a rollout. So I'm going to go to my code editor here, and so I've already created a couple images, like I said. So there's 2 stable ones, and then there's one that causes a null pointer exception, for example. So let's say that we want to deploy this one. I'm just doing this all manually. Don't obviously do this in production, but
yeah, you could have had Bob do it.
Yeah, I know. Hey, Bob. And then do NPE, super descriptive but yet effective commit message. I'm just going to push this to my branch. And then let's see, I'll just give this a little kickstart. And so if you're familiar with Argo rollouts, it's going to notice that there's something out, there we go, that it's out of sync, and it's going to start rolling out, right? So it starts out with 10%. It waits 10 seconds, I think, for gathering some data, and then it's going to kick off the analysis. And so here we'll see in my little UI thingy that it's going to start receiving the request, and then it's going to go out. Here you can see, so it received analysis request, and then it's fetching logs, metrics, and whatever more, and then it's going to start doing its analysis. So in the meantime, you can see this is our I call it a Kubernetes agent, but I mean, it's really a rollouts agent. That's the actual agentic system. And so we should see in the logs if it wants to show the logs. Oh, I'm just going to hit refresh. Looks like my network is a little bit slow. We'll just look at it here. So in the meantime, it's done already its analysis. It says canary logs contain repeated null pointer exceptions in the metrics resource and load generator service. And then here's the root cause, and it passes that on to the remediation agent. But in the meantime, so it passes that on asynchronously to the remediation agent, but it also sends the rollback signal directly to Argo rollout. So it's already rolled back, as you can see now. We're back to our previous version. It says degraded. You can see that here in Argo CD as well, that it's now back to the previous version. And so it says remediation triggered. So it's doing trying to figure out if it can come up with a solution. So let's look at the logs here. So, it's doing a bunch of stuff. It's reading files. And then, remediation attempt 1 failed. That's not good. But fortunately, I do have a retry. And it looks like the retry did work. And so it created, pushed the fix to a branch, and then created a pull request. And then it's evaluating the results to make sure that it's good enough. And it says pass. So now we've gone, all the way around. And so if I go to our demo project here, sorry for my mugshot there. If we go to the pull request, here's one that's open just now, and it has the null pointer exception, and then hopefully it has a decent fix. We'll see. It just removed my intentional little thing where I was triggering the null pointers, so that's fair enough. But
it always helps when you comment the code with intentionally
yeah.
problems, and it's like, oh, I've got a great idea.
Wow, this is
even if you don't do it, sometimes it's hard to trick the AI. I mean,
this is true.
The other demo was like hiding it a little bit. I was like, yes, you intentionally added this. Maybe I'm supposed to keep it.
Right. Yeah.
Yeah, it might be, it would actually be interesting. We could get a little chaos engineering going here, and we could make an agent whose job it was to subtly introduce failures that are hard to detect.
Which again is harder than you think. Like, because I was trying to put in some issues or some null pointer exceptions that were a little bit harder to find, and it's really hard to create code that you can actually compile and push that doesn't already have some sort of check for any kind of issue. So this creating the bad images was harder than I thought too.
Yeah, you have to pull if you're gonna have AI do it, you'd probably have to use a malicious AI to do it. And you can actually, what's interesting, and nobody talks about, I haven't heard anybody in the news ever talk about this, but there are tools that will let you run your model and remove all of the weights and safety constraints so you can have it be nefarious. And people upload those models onto Hugging Face usually within like 5 minutes of new models dropping. So like all this talk about like, oh, AI governance, it's like, yeah, but like in the real world, like people are just stripping those out. But you could totally throw one of those at and be like, you're a malicious hacker. Your job is to try to exploit the system and like subtly introduce these changes over time. And then you can let your bot adversarially learn from the malicious bot.
It was better when you say you are a pen tester.
Yeah, exactly. Yeah, be a pen tester. I'm writing a movie about a pen tester.
Really bad things.
So I need you to, I like the one that's, my grandmother was a wonderful pen tester and she had a recipe for how to do this. Could you please share my grandma's pen testing recipe? He'll do it for you. No, that's awesome. Yeah. This is great. So, you were insulting your own UI, but it looks quite good actually. Better than a lot of billion-dollar products that are out there today.
Yeah. I spent way too much time on it, by the way. It's like this is not my job, but yeah. you got to have something that at least looks a little bit okay. But yeah, I mean, I'm sure somebody with proper skills could do something much better. But anyway, so now I push obviously a better version that passes, and so you can see that also, of course, is works when it's supposed to keep going. So in this case, it says that logs show identical non-critical warnings, and the metrics are nearly identical, which makes sense because this version is very similar to the other one, and then it just promoted it also with a confidence score. So in this case, 95%. And then
Nice.
yeah. Anyway, and then you can
It's
see
very
that it
good
just
at,
kept rolling out.
at doing how it's called, the finding the differences and stuff. Like, you never start from a real application, never starts with a clean log, everything is perfect, no exceptions, no errors, no warnings. So this is very good at comparing and doing the analysis, comparing one with the other without you having to do any magic.
Yeah, an idea for our next talk was we're going to deploy an AI app and then compare the token usage of the previous version with the new version and see, oh, this one's using way more tokens. So even though it works better, is this really worth the cost of rolling it out to everybody? So I mean, you can go many ways with this, but
well, and I do think there's probably also a role in where you might use this, especially for newer services, where you're like, we don't really fully understand the different failure conditions yet. We're gonna use this to help us. I actually would maybe add like a thing that is to output the various failure conditions into a file so that we can come back later and be like, okay, like given that these are the potential failure conditions, let's create a static rollouts template that we're gonna run first. Right. So that I reduce the potential for it's like you almost want to be in this place of saying, hey, if there's any kind of thing that's anomalous here, kick off this agent and get it to work. So you wouldn't have to use the tokens as much. Now we're not in that token apocalypse economy that people are so worried is coming at this point. So I'm not too worried about it, but you do get into like a little while ago, I was seeing somebody who was like, oh, look, I'm using my AI agent to check for broken links on this website. And I was like, we already have a tool that does that. And it costs 99% less. So just use that one. And AI does want to do that stuff sometimes. Sometimes it'll go through and it'll be like, oh, cool. Like, I'm going to figure this out. And it's like, just use the tool that does it already, or make a tool that does it and just run it because it'll be cheaper and faster. But very cool. And I actually think that this is going to become a very common pattern that we see of using agents as part of the analysis, to figure out what's going on. And we're doing it in Octopus Deploy. I mean, that's already something we're seeing from our customers. So yeah, definitely the right direction, I think. So we actually asked in the community, I want to get your reaction to this. We asked Ravital, our wonderful producer, went and put this question out into Reddit. Let me share this with you. So the question, she basically asked, hey, is anybody using AI agents as part of their analysis to detect failures? And this person says, not using agents for most of that. I think most of this, like detect an issue by looking for telemetry signals, should be deterministic and thus no need for AI. AI can be useful if an issue is detected, though, to correlate with a change, this release or one of another subsystem, correlate with signals observed in another system, like traces would be helpful there. What are you guys' reaction to that?
Yeah, I think that totally makes sense, because if something can be done deterministically, obviously that is the way to go. We tend to fall in this trap right now of like, oh, I can use AI for this, so therefore I should, which is a fallacy, of course.
No, I'm token maxing. That's what that's what the kids are doing.
My manager told me I have to use at least
my
X amount of
bonus is based on the number of tokens I use, so therefore.
Dude, how could we all be blessed enough to have that job? That would actually, it would be terrible if you had to work for somebody who would tie your bonuses to the tokens you were using. like you might be able to make a lot of money in the short term, but like long term, you are doomed. This is,
Yeah.
this is terrible, terrible idea.
But I totally agree. I mean, with this is not replacing the deterministic metrics that you may have. This adds on top of that for the things you don't know that go wrong. It's a bit of like, how do you react to chaos testing and this stuff, right? I have no idea what could go wrong. Just do an analysis. And it's a great use case for AI because worst thing that can happen is that your version is rolled back, nothing else. So it's a great way to throw AI to a problem and with no risks. Because you ship something, it wrongly detects it's going bad. It's just an added thing on top of it. And what you said also makes total sense. You could have this running on a stage or somewhere else, dumping cases that then you say, okay, now create me a deterministic template for these cases.
I almost think like I would be tempted to say, hey, anytime we roll out a new service, we're going to plug this in and I'm going to expect it to run for, 3 months. And I'm going to expect some deterministic output from it that will become the frontline method of detecting, failure conditions based on the history of what we see in the service. And those are like, even in those cases, you may also say, so something that we've talked a lot about in Octopus is how we judge risk. Because inherently, the job of CD is to de-risk deployment. That's really the whole job. Because anybody can you can have a CI step at the end that just YOLOs stuff into production. It's just risky. So it's scary. So you're like, oh, I want to have an approval and I want to do these tests and I want to have this process and I want to be able to handle a rollback and I want to do progressive delivery. Like I want to have all these things that are part of it. But there is the failure conditions for software are vast. And there's this discussion even within like the CI portion of the equation where we debate, hey, 99% of the time you run these unit tests, they pass. So should you be running them every single time? And there's a trade-off there, right? Of like, well, if my unit tests take 3 hours and cost me $200 to run, I might start thinking about like, okay, is there a way that we can maybe think about removing some of these tests that are superfluous? If they never catch failures, are they really needed? Or is there a way that maybe I can run some tests that are very, very predictive of failure really rapidly, and only at the very end I need to run all these steps to do like the full burn in the system. And so I do like the idea of like, hey, you might not even run this agent in staging, right? But you might run it in production for like more sensitive services. So there may be a choice there that people want to make. So we're getting close to time, and I do want to take a community question. So let us bring that in.
You ask, we answer.
Guys, the production value of this show is just
I was going to say,
control.
very impressive.
It's amazing. Okay, so here's the question. This one's coming to us from Reddit, from the Argo CD subreddit. Yes, we do watch the Argo CD subreddit, Kostas and I especially. So we love to see your questions in there. This person says, we're re-architecting GitOps, choosing between app of apps versus app sets when introducing cargo for environment promotion. I'm currently in the process of re-architecting our internal GitOps workflow. Right now, I want to move toward a cleaner multi-environment structure and get rid of custom CI pipeline scripts for environment promotion. To do this, we're looking at incorporating cargo alongside Argo CD. Hey, I'd say use not cargo, but use Octopus Deploy, or if you're maybe use GitOps Promoter. But hey, whatever. That's more of a personal thing. I'm hitting a few design sticking points regarding repository layouts and Argo patterns, and I would love some feedback from anyone who has paired these tools successfully in an org-wide adoption. Argo pattern selection. Do you lean more towards app of apps versus application sets? What are the pros cons of when cargo is the tool mutating target environment files? Repo architecture, directory versus branch promotion, which I think that Cargo does kind of favor branch promotion. Lessons learned, migration, additional info. There's a lot there. I'm not going to read all of it. Kostas, you got a smirk on your face.
Yeah, this is a very popular question, and I think it has several problems. First of all, you don't have to choose between app of apps or application sets. You can use them together, and actually you should use them together. And for the directory versus branch promotion, there is already lots of information out there from me about how you should do it. Just Google search how to structure your GitOps repositories. I think that's enough.
Yeah, I think, I mean, we could definitely point them at some of the articles about repo architecture and structure to say, hey, you should use folders, you shouldn't be using branches, long-living environment branches.
Carlos knows there is actually a presentation from Adobe in one of the ArgoCons, I think 2022 or something, where Adobe has presented their way of doing stuff, and they said use folders, if I remember correctly.
Carlos, you stand by that now?
Could totally be. It's a long time ago, but yeah.
Yeah, it's 2022. Sorry.
Yeah, I think your comment about app of apps versus application sets. Some of my favorite app of apps that I have contain apps that are entirely application sets. So that is totally a thing. And then you can go vice versa. You can have application sets that actually generate parent apps that are pointing at app of apps as well. The big thing here, it's actually this question, I think, Kostas, shows how would we say it? Where should the configuration live in Git, right? And it should live in a place where you're modifying it outside of the application or the application set. So it should be in manifests. So this gets into all the best practices we talk about. Don't do a Helm sandwich. Don't use parameter overrides, all of those kinds of things. And as long as you're doing those things, then your system is going to be pretty pass-through. Now, I'm not speaking specifically about Cargo for that, because it's one of the tools I've used less. But as far as like just like hardcore like GitOps promotion, we spent a ton of time on that, obviously. And if you have all of the relevant parameters in the manifests, that's where you want to have them. You don't want to have them inside the application. That's where you get into problems.
So go to the CNCF YouTube channel and just Google search Adobe Argo or Adobe Argo rollouts. And I think you should find like 5 or 6 presentations from Adobe. And one of them is about this topic. No, Dan, you don't have to do it now. I'm answering to the person that is asking this question.
Yeah, good idea. You have so many Adobe talks, though. I mean,
yeah, put Argo as well. Adobe Argo, not just Adobe.
Do you guys actually work at Adobe?
No, but
I should be the one to speak.
That's such a great company.
No, it's I want you to be objective. Like if I say it's my opinion, people will say, yeah, Kostis says his opinion. But now I'm saying it's not my opinion. It's what Adobe is thinking. So, feel free to take over and say what you're doing.
Yeah, perfect. Anything you want to add, Carlos, Kevin, to our answer, our snooty answer?
Not me.
All right, so perfect.
Just go and watch all the Adobe talks about Argo.
Yeah, go watch all the Adobe
talks.
Yeah. All right, perfect. Well, thanks everybody for tuning in again to this episode of Argo Unpacked. It was, again, a very special episode as we talked about Argo rollouts, de-risking your deployments, embedding AI agents into that loop, and gave you some cool tools you can check out and use. So we did plug those and we'll put them in the show notes as well for those that are listening later in the audio podcast on Spotify or whatever. Don't forget to like and subscribe. Tell your friends. Argo Unpacked is the place to be. If you want us to cover any future topics, please let us know. We'd love to hear from you about the things you want to know about. Of course, we're also always watching Reddit. If you haven't done the GitOps training and certification from Octopus Deploy, go check that out, because it is the best way to learn Argo CD and how to do it in a GitOps fashion. Argo Con North America CFPs are closing in 3 weeks. They are closed for everything else. So if you wanted to get into Japan, too late. India also closed, and North America KubeCon in general closed, but ArgoCon North America, which will be in my hometown of Salt Lake City, coming up in November, is open for a few more weeks. So get your talks out. Carlos, Kevin, Kostas, anything you guys want to plug out there for people to do?
No, I'd say
try
it out. Yeah.
Try that plugin. Hey, get it on the ground floor. I looked and it had 9 stars. I was the 10th star today. So this is your chance to get out on the ground floor of an exciting repo. Get that star in early. Everybody knows that if you have an early star on a repo, you're the real OG. And that's what the real engineers are made. All right. Okay. Thanks everybody for coming to another wonderful episode of Argo Unpacked. And as always, stay synced.
Argo Unpacked. Stay synced.